Hi everyone, this is Naren and here's my teach one for question 5 in propensity scoring for the class of HAP 823 comparative effectiveness analysis using observational data. So here's the question I have worked on. In this question we have been given a data set which has patient records. Each record refers to a patient's overall satisfaction, the time spent by each nurse with him or her, the patient's comorbidities, and his or her age. This file can be downloaded using the link provided in the slide. The main aim of the question is to find out if any of the nurses have a significant impact on the overall satisfaction in the unit. To solve the problem, we initially have to load the data from Excel sheets into RStudio. Since the data is in Excel format, I would use the read Excel library and then read_Excel command to read the data from Excel sheet into the data frame named data_sat, and then use the view command to look at the data. To answer the question of does any nurse have significant impact on the overall satisfaction, I shall start working with nurse 1. Since satisfaction is a continuous variable, I shall linear regress satisfaction over all the independent variables except for nurse 2 and nurse 3. And I shall give the name of the model as nurse1_reg. And then I use summary command to look at the summary. By looking at the summary, we can state that every independent variable has a significant impact on the overall satisfaction. But then we have to make sure that nurse 1 has no correlation with all the other independent variables. In the next slide, let's check if there is any confounding between nurse 1 and other risk factors. So, to test for if any confounding exists, I shall regress the nurse 1 variable on all the other independent variables except for satisfaction, nurse 2 and nurse 3. I have given the model a name of nurse1_test, and when I look at the summary, I get to know that myocardial infarction coded as MI and injuries have correlation with nurse 1. So it is our job to remove this confounding and then build a final model to check if nurse 1 has any significant impact on the overall satisfaction. Now, so as to remove confounding, we use the method of propensity scoring. In this method, there are 3 steps. The first step is to calculate propensity for the variable of nurse 1. The second will be balancing covariates using inverse propensity weighting. And then finally, we calculate the impact of treatment in the balanced data. The first step in turn has 3 sub-steps, wherein since the nurse 1 variable is not binary, we first convert it into binary, then build a logistic regression out of the binary variable, and then calculate the propensity scores. In the next few slides, I shall go over each step sequentially. So as to binarize the nurse 1 variable, I first calculate the mean of the whole column. And then if a row has a value which is greater than the mean, I code it to be 1 and otherwise to be a 0. To do this, I use a if-else condition, then place the condition in the first parameter. Then if the condition is true, I set it to be 1, else 0, and name the column as nurse1_b. And the second step would be I create a logistic regression model wherein I regress nurse1_b on all the other independent variables except for satisfaction, nurse 1, nurse 2, and nurse 3, and name the family as binomial to indicate that this would be a logistic regression. Then I look at the summary and I still see that the confounding exists. In the next slide, let's calculate propensity scores. So as to calculate the propensity scores, I use predict command on the nurse1 underscore prop logistic regression model which has been created in the previous step, and then it is on the data of data underscore SAT. Then I set the type to be response. I set the propensity scores to a column named PS in the whole dataset. Then I use the view command to look at how the data looks, and we can see that a column named PS has been added to the end of the data frame. Now that we have propensity scores, we can use inverse propensity weighting method to calculate the weights for the whole dataset. To calculate the weights, we have to remember the formula of weight would be equal to nurse over propensity plus 1 minus nurse over 1 minus propensity. Since nurse is a binary variable, when it is equal to 1, the formula would drop down to 1 over propensity, and when when the nurse variable is 0, it would drop down to 1 over 1 minus propensity. To do so, I have used a if-else command in R and checked for the condition of nurse1 to be a 1, and if that is a yes, I would calculate weight to be 1 over the propensity score, and if not, the value would be set to 1 by 1 minus propensity score, and I name this column as W to represent weight. And when I look at the data, we see that a column named W has been added to the end of the data frame. Now that we have weighed the data, we can go ahead and calculate the impact of nurse1 on overall satisfaction. But just before doing so, let's just check if the data is balanced or not. To do so, I again have a logistic regression model in here wherein I regress the nurse1 binary variable on all the independent variables except for satisfaction, nurse1, nurse2, nurse3, the propensity score column, and the weights column. I set the family to binomial, and just in addition that I have a weights option set to the column W. When I look at the summary, I see that the confounding has been removed. So now we can go ahead and build a final linear regression model to check if nurse1 has an impact on overall satisfaction or not. Let us do that in the next slide. Now again, I create a linear regression model wherein I linear regress satisfaction over all the independent variables, removing the unnecessary ones, and I set the weights to be W. I use the summary command to look at the summary, and I can still say that nurse1 has a significant impact on overall satisfaction. To conclude, I can say that nurse1 has significant impact on the overall satisfaction, but when compared to the other factors, nurse1 truly has lesser impact. And then we can repeat the same process for nurse2 and nurse3, and we can decide amongst the three who has a higher impact. This is how we solve question 5 for propensity scoring. Thank you for your time.